warm welcome to all. Today I am going to explain about zero current switching L type converter. First, there are two types of switching methods. One is called as hard switching, another one is soft switching. Today we are going to study about soft switching method. What is meant by soft switching? The switching device are turn on and turn off when the voltage across the device or current becomes zero. The switching device are forced to turn on and turn off through zero crossing by using LC components. The switches are turn on and turn off by using the LC components. Hard switching. In hard switching, the switches are turn on and turn off at any time at some high voltage or low voltage, or high current and low current. Due to that, there are some drawbacks in the hard switching. The switching loss is very high, high di by dt and high dB by dt. There's a high power loss, electromagnetic interference is there, and voltage stress to the switches. These are the drawbacks of the hard switching. So we are going to discuss about the soft switching. In soft switching, there are two types. One is called as zero current switching, another one is zero voltage switching. In zero current switching, there are two types. One is called as L type, zero current switching, M type, zero current switching. In zero voltage switching, one type that is called as M type, zero voltage switching. Comparison between zero current switching and zero voltage switching. Zero current switching. The switches are turn on and turn off during at zero current. The switches are turn on and turn off at zero voltage. In ZCS, there are two types, M type and L type. In ZCS, only one type, M type. ZCS converter is used for variable load. ZVS, it is used for constant load. ZCS is used for medium switching frequency. ZVS, it is used for high switching frequency. ZCS, it is operate on-time control, constant on-time control. ZVS, it is operate on constant off-time control. We have studied in DC chopper. There are two types of control techniques. One is on-time time limit control, another one is current limit control. In current limit control, there is only one type. In time ratio control, there are two types. One is called as constant on-time control, another one is constant off-time control. Now I am going to explain about the ZVS, zero current switching L type converter. So as I previously told, there are two types of converter, and this is called as L type converter and this is called as M type converter. But today class I am going to explain only about L type converter. This is the figure 4.50 is the circuit diagram for L type converter. Vs is the supply voltage, S1 is the switch, LC is called as a resonance circuit, diode D is called as a freewheeling diode, L1 and C1 are called as a filter, and R is called as a load, V out is called as an output voltage. This is the main part of the ZCS L type converter. It consists of 5 modes. At the previous I told L1, C1 is filter circuit, LC is called as a resonance circuit, S1 is called as a switching device. We can use various types of switches. SCR, BJT, MOSFET, and IGBT. The load current is IO is constant. Here we have to use an high inductance. So the filter inductance is very large. Initially, the IL value is 0 and voltage across the capacitor is 0. The current flowing to the inductor is 0 and the voltage across the capacitor is 0. The switch 1 is open. The load current I0 flows through the freewheeling diode. There are 5 types of mode. So it is comes under mode 1, mode 2, mode 3, mode 4 and mode 5. First we can see about mode 0. This is a diagram for mode 0. So mode 0, the time will start from 0 to T1. And mode 2, T1 to T2. Mode 3, T2 to T3. Mode 4, T3 to T4. Mode 5 is T4 to T5. This is the 5 modes. This is the time period. At time T is equal to 0, we have studied initially the switch is open. But at time T is equal to 0, the switch is closed. So the source voltage is called as Vs. Here, when the switch is closed, IL current is rise from 0 initial value. The IL current, this is called as IL current, it will start increasing. So initially, the switch is open. So this is a short circuit. The output current will flow through this freewheeling diode. So it's a short circuit. So that is a voltage is 0, VD is 0. And here we'll have the capacitor. The capacitor is also 0 voltage. Vs is equal to L into di by dt. You know the voltage Vs is equal to L into di by dt. When the switch is closed, ID is equal to I0 minus IL. Here, the current flowing to the diode is one is called as IL, another one is called as I0. So the current flowing through the ID is equal to I0 minus IL. So IL is nothing but Vs by L into T. Substitute here, so we will get the value like this. Now at time T is equal to 1, IO output current and inductor current is equal. When these two currents are equal, so the current flowing through the diode is 0 because these two currents are opposite direction. So it is 0. So the diode will get turned off. Short circuit across C is removed. So now the short circuit across the capacitor is removed. So what happens? The capacitor will be connected at the end of time T1. Next we can, this is the waveform for mode 1. The capacitor is not connected, so voltage is 0. Capacitor current also 0. The switch is open, so the voltage across the switch is 0. At time T is equal to 0, the switch is on, so the inductor current start increasing. Initially, the load current flowing to this diode, and the load current is start decreasing. And when it comes to time T1, the diode gets off because I out is equal to IL. So this current is called as 0 current. Mode 2. This is a diagram for mode 2. Now the diode is removed and the capacitor is connected. So now the current will flow from Vs, L, and here we are having one L1 as load and will come to the negative. During this time, the current will start charging. So what that means, the current value is initially 0, it will start increasing. Here IL, this is the IL current is divided into two. One is called as IC, another one is called as I0. So IL is equal to I0 plus IC. IC is called as capacitor current, is called as IM, maximum current sin omega t. Substitute here, you will get as IL is equal to I0 plus IM sin omega t. You know, omega naught is equal to 1 by f. Angular frequency is equal to 1 by root LC. Substitute the value here. So Im is equal to Vs into square root of C by L. That C by L is nothing but impedance. So Z naught is equal to root of L by C. So the value of Vc is equal to Vs into 1 minus cos omega t into t. IP value, peak value of the switch occurs at time t is equal to pi by 2. Pi by 2 is called as 90 degree. Substitute here. So you will get us, already your formula is omega t. So t value is this one. Omega value is 1 by root LC. This root LC and root LC will get cancelled. So we will get this term Vc is equal to Vs into 1 minus cos pi by 2. So the cos 90 is equal to 0. So we will get us Vc is equal to Vs. So at time 90 degree, the capacitor value is Vs. Now Ic is equal to Im sin pi by 2. Sin pi by 2 value is 1. So 1 into Im is equal to Im. So at 90 degree, the capacitor value current is called as maximum current. So the peak current is called as I naught plus Im. Next, at t is equal to t by 2. T is equal to t by 2 means at the end of mode 2. So that is called as 180 degree. So 180 degree by omega. Omega is nothing but root 2 LC. Substitute in this formula. So you will get us Vc is equal to Vs into 1 minus cos pi. Cos pi is nothing but minus 1. Minus 1 by 1 you will get us 2 Vs. So now at 180 degree the capacitor value is 2 Vs. So sin pi is equal to 0. So the capacitor current is 0. So at 180 degree or at time t is equal to t2, the capacitor current is 0 and voltage across the capacitor is 2 Vs. At time t is equal to 0, IL is equal to I naught. Inductor current is equal to capacitor current. So the peak current is I naught plus Im. It will goes to I naught. So the peak current, it will start decreasing from maximum to it will comes to I naught.